Dear students, in the last session, I had explained the mesh analysis method. In this session, I will explain the nodal analysis method. This is the second method is used for solving any electrical network. First, we must know about the definition of the node. Node is a point in a network where two or more elements are connected. In nodal analysis, we will consider the node voltages with respect to ground. Hence, nodal analysis is also called as node voltage method. Nodal analysis is the application of the KCL. In the first session, I had explained the KCL. That means Kirchhoff current law. It states that the sum of current flowing towards the junction, that means node, is equals to the sum of current flowing away from the junction. Next, to analyze the DC circuit by nodal analysis method. First, we must identify the node. Node is a point where the two or more elements meet at a point. From the circuit, say E1, E2 and E0 are the nodes. That means the potential of the node is E1, the potential of the node is E2, the potential of the node is E0. The node E1, the node E2 and the node E0. One node, we have to take a reference node, say E0. Reference means in this we will take potential of the node is 0. That means E0 equals to 0 volt. So, E1 and E2 are the significance node. So, we have to calculate the voltages of E1 and E2 nodes. Once the voltages E1 and E2 knows, we can calculate all the branch currents. In the circuit, let I1, I2, I3, I4 and I5 are the branch currents of the respective elements. Let E1 and E2 are the nodes, voltage at the node 1 and 2 respectively. By applying the KCL to the node 1, to the node 1, I1 equals I2 plus I3. That means the KCL states that means the Kirchhoff current law states that the sum of current flowing towards the junction is equals to the sum of the current flowing away from the junction. The current I1 is flowing towards the node and the current I2 and I3 flowing away from the node. So, I1 equals I2 plus I3. Based on the direction of the current, the potential difference between the 2 points, that means V1 and E1 to the total resistance, that means R1. That means V1 minus E1 divided by R1. Depending upon the direction of the current, the starting point is the V1 and the ending point is E1. That means V1 is a higher potential when compared to the E1. Similarly, for I2, E1 is the starting point and E0 is the ending point. E1 is the starting point and E0 is the ending point. Next, I1 equals, V1 minus E1 divided by R1. I2 equals E1 minus E0. E0 equals to 0 volt, no. E1 minus E1 divided by R2. The same thing, I3 equals, starting point is E1, ending point is E2. E1 minus E2 divided by R3. E1 minus E2 divided by R3. By solving, you will get the equation 1. By applying the KCL to the node 2, to the node 2, I4 equals I3 plus I5. I4 equals I3 plus I5. That means I4, the current I4 is going away from the junction E2. The I3 and I5 is going towards the junction. Therefore, I4 equals I3 plus I5. I4 equals I3 plus I5. The same thing, I4 equals E2 minus E0. E0 equals to 0 volt divided by R4. I3 equals E1 minus E2 divided by R3 plus I5 equals V2 minus E2 divided by R5. By solving, you will get the equation 2. Solve the KVL equations either by elimination method or Cramer's rule to find the voltage between the nodes in an electrical circuit in terms of branch currents. Problems on nodal analysis method. Calculate the currents in different branches of the following network by node voltage method. This is the given circuit. Let I1, I2, I3, I4 and I5 are the branch currents of the respective elements. Let E1 and E2 are the voltages at the node 1 and 2 respectively. Node 1 and 2 respectively. By applying the KCL to the node 1, I1 equals I2 plus I3. I1 equals 20 minus E1 divided by 1. I1 equals 20 minus E1. That means depending upon the direction of the current, the starting point is the 20 volts, the ending point is the E1. So 20 minus E1 divided by 1. 1 means total resistance. That means 1 ohm. The same thing for I2. I2. The starting point is the E1. The ending point is the E0. That means E1 minus E0. E0 means that's equals to 0 volt. E1 minus E0 divided by total resistance. That means 2. E1 by 2. E0 equals to 0 volt. The same thing, I3. I3 equals, depending upon the direction of the current, the E1 is the starting point, E2 is the ending point, E1 minus E2 divided by total resistance 2 ohm. So E1 minus E2 divided by 2. That is 40 minus 2E1 that's equals to 2E1 minus E2. 40 equals 4E1 minus E2, say the equation 1. By applying the KCL at the node, to the node 2, I4 equals I3 plus I5. That means I4, the current is flowing away from the junction. I4 equals I3 plus I5. I3 and I5 is going towards the current is flowing towards the junction. So I4 equals I3 plus I5. So I4 equals depending upon the direction of the current, E2 minus E0. E0 equals to 0 volt. So E2 divided by total resistance means 1 ohm. E2 minus E0 divided by 1. Next. I3 equals E1. Next, I3 equals, I3 depending upon the direction of the current, E1 is the starting point, E2 is the ending point, divided by 2. E1 minus E2 divided by 2. The same thing for I5 equals 1. I5 equals I5 1 minus E2, 1 minus E2 divided by R3. Divided by 3 ohm. That means divided by 3. Therefore, E2 divided by 1, that's equals to E1 minus E2 divided by 2 plus 1 minus E2 divided by 3. By solving, you will get 2 equals minus 3E1 plus 11E2, say the equation 2. These two equations, that means equation 1 and equation 2, can be written in the matrix form. In this, we have the left hand side of the system with the coefficient matrix and the right hand side with the answer values. That means, in the left hand side of the system with the coefficient matrix, that means the coefficient of E1 and E2, and the right hand side with the answer values. Answer values means 40 and 2. Next, delta be the determinant of the coefficient matrix of the above system. The determinant of the given matrix is 11 into 4, 44, minus into minus, and 3 ones are 3, minus 3, that's equals to 44 minus 3, that's equals to 41. Next, delta E1 be the determinant of the matrix formed by replacing the first column values of the coefficient matrix with the answer column values. That means the first column values means 4 and minus 3 is replaced by the answer column values. Answer column values means 40 and 2. Therefore, the determinant of the given matrix is 40 into 11, 440 minus of minus 2 plus 2, that means 440 plus 2, that's equal to 440 volts. Let delta E2 be the determinant of the matrix formed by replacing the second column values of the coefficient matrix with the answer column values. That means the second column values means minus 11 is replaced by the answer column values for 40 and 2. Let the determinant of the given matrix is 4 into 2, 8, minus 4 3 is 12, 40 into 3, 120, minus of 120, that means 8 plus 120, that's equals to 128 volt. Next, we have to calculate E1 and E2. you know E1 equals to delta E1 divided by delta, that's equals to 442 divided by 41, that's equals 10.78 volts. Next E2 equals to delta E2 divided by delta, you know the delta E2 equals to 128 volts, that means 128 divided by delta equals to 41, 128 divided by 41, that's equals to 3.12 volt. Once the voltages E1 and E2 knows, we can calculate all the branch currents. That means I1, I2, I3, I4, I5. You know, I1 equals 20 minus E1 divided by 1. That means the potential difference between the 2 points divided by the total resistance. 20 minus E1 divided by 1. 20, you know the value of E1 equals to 10.78 volts. So 20 minus 10.78 divided by 1, that's equals to 9.22 amp. Next, the I2 equals E1 by 2. That means you know the value of E1 10.78 divided by 2, that's equals 5.39 amp. I3 equals E1 minus E2 divided by 2. You know the value of E1 and E2. 10.78 minus 3.12 divided by 2. That's equals 3.83 amp. I4 equals E2 3.12 amp. I5 equals 1 minus E2 divided by 3. You know the value of E2 3.12. 1 minus 3.12 divided by 3, that's equals 0.7 amp. Like this, we can calculate all the branch currents. Thank you.